Hello everyone. In this lecture we will learn about what are data objects and different attribute types. So please like, comment and share this video. So we will learn about different type of data sets. Different type of data sets, we have the record data, order data, graph and network data, spatial, image and multimedia data. So I will go with you what are the how each data will look like. So talking about the record, so records are the rational records. You might have seen the Excel database sheet. There we have different type of data. There's different rows and columns. Yeah, we have, sorry, we have different rows, and each row resembles the data record, and we have different columns that refers to the attributes or the dimensions. We will learn more in the upcoming slides what are these, what why I'm calling them. So so data matrices, example numerical matrices and cross tables, are the similar thing that I am talking here, that I have explained here. So you can either call them the cross tables, cross tabs, anything. So that basically refers to the record. So record data. So the other type is the document data. So document data is similar to the table. I have example for you. So if for example, we have three documents. In document one we have the team won the game. In second document we have the coach lost the game. In third document we have the team and the coach prepare for the game. So we created the table. In the table is divided, each row has the different wording like the team won coach, and we have different documents that tells you how much time that word is repeated. For example, the word in the first document is repeated twice, so we put 2 here. Similar with the document 2, similar with the document 3. So that what is the document data. And the third one is transactional data. So I think you might know what is the transaction. So our transaction, like all the things we are paying, you go to shopping mall and you pay for a bill there, so your card history is recorded in the tables, that what we have discussed here. So that is the record data. I hope it is clear. So coming to the graph and network, the graph and network. So the graph and network is mostly the network data. So the reason you see the World Wide Web here under the graph and network is because we have different links on the different web pages. So links between the web pages create a network of connection, similar with the social or information network. You have seen your friends on Instagram, so basically it represents your connections or a network. The molecular structures, moleculars are made of different atoms that have the different network that makes the molecules. So all the examples here are kind of network data. So now coming to the order data. Order data is kind of a time series data. You will see the video data. Video is the sequence of images. So as the time changes, as the value of t changes, sorry, as the value of t changes, we have different data, same temporal data, that is the time series data. At different time we have different data. The sequential data, that's a transactional sequence. So your transaction, the way you make your transaction, the patterns of your transaction. For example, you are buying one thing at particular time, second thing at a particular time. That makes the patterns that we will use them in this machine learning course, how it's more predictable. And the genetical sequence data, it means DNA, RNA that's changing according to the time, according to one generation, second generation. That is order data. So the fourth type is the spatial image and multimedia. Spatial is a kind of data according to different space. For example, in an image at different pixel we have different data value, different RGB value, different intensity. So it changes according to the place. The maps are the example for this as well, because in map different location have different data. Video data is here as well, because video is made of images. So at particular time t, so you will see we have one image. So basically an image can be divided into different parts, different pixels that represent different data. I hope the types of data set it is clear to you. If any question, please leave a comment and we will get you back. We will answer your queries. Now we will learn about the important characteristics of the structured data. So structured data, it is the data that is organized in a predefined format, such as rows and columns. Examples are database or spreadsheet. So in this we already have predefined format. So we will learn about the characteristics of that data. The first one is dimensionality. So it's the number of features, number of attributes, number of columns, that what it says. So give me, yeah, number of features is most more appropriate word here, not columns, because we can have garbage columns as well. Number of features, that what is dimensionality. So it has one disadvantage, curse of dimensionality, we say. So in this you will notice, as we have more dimensions, more columns, as the dimension increases, volume of the data space we need increases exponentially. So it's increasing because we have more data in, and we have to consider that data for every each single record. So it's increasing uh, exponentially, and this can lead to the overfitting of the data. We will learn more about the overfitting in upcoming videos. Overfitting, let me write it down. Yeah, the second characteristics we are interested about the data is sparsity. Sparsity refers to the data set where many of the features are zero or absent. Zero or absent. Yeah. So it has one disadvantages, that only presence count, because most features are zero and only the features that are present is are significant. So our model will be more biased towards the features that are present. And talking about the resolution is the level of detail at which data is collected or analyzed. Let me write it down as well here. Sorry. Oh, sorry. Level level of level of detail. Yeah. So it has one disadvantage is that patterns depend on the scale. Means the patterns depend on a resolution. For example, the daily sales data will be different to the weekly sale or the yearly sale data. So we have to see the scope of the resolution, how much details we want to go deep into, like collecting the while collecting the data. Do we want to go weekly sales or the daily sales? That you have to think before collecting the data. The four characteristics of the data is the distribution. Distribution is mean, medium, mode, how the data is distributed, centrality, basically have mean, medium, mode, and dispersion is more about standard deviation and variance range. Now coming to the data objects, so it's more clear if you will read the text here. I will read it with you. So data sets are made up of data objects. So initially we talked about the data sets. They are the record, they are made up of different records or the different data. So but the data sets are made up of data objects. Objects refer to one data record or the entity that we discuss it in a in previous slide. Yeah, different entities. So data object represents the entity, and example are sales database that have that stores customers, stores items, sales. Medical database, patient treatments, university database, students, professor, courses. So for example, in the database we have students table and each record represent the data object. So also called sample, examples, instance, data points, objects, tuples. So these are the different names of the data objects. Data objects are described by attributes, like we have different row value as the column value changes. For every student we have different height, different age. So our data objects are described by the attributes. So database rows are the data objects, columns are attributes. I hope it's clear. So talking about the attributes, uh, so we can call attribute dimensions, features, variable. They all will refer to the different values we are storing in our database. They are the data field representing characteristics or a feature of data object. Example, customer ID, name, address. So there will be a different types of attributes. Nominal are the category data. We will learn in next slide. So binary data, again we will learn more in next slide. It's binary is a special kind of a special type of the nominal data we in which we have only two categories. Numeric, that's a quantitative. So we have different type of numeric data, interval scaled and ratio scaled. We will learn in next slide. So the nominal data are the categories, states, or the names of the things. Here is the example. Here color, black, blonde, brown, gray, red, white. They are different categories of hair color. So marital status, divorce, single, never married. Occupations, ID numbers, zip code, they all comes in the nominal data because we have different categories of the value in the data record. So binary is the nominal attribute with only two state, 0 or 1. So that means binary. Symmetric binary, in which both the outcomes are equally important. Equally important word is important here. And asymmetric is outcomes not equally important. Example, medical test, positive or negative. Convention. So for convention we are assigning 1 to the most important outcome and 0 to least important. So There is one ordinal. Ordinals are value have the meaningful order ranking, but the magnitude between successive value is not known. For example, small, medium, large. We have different values, but the magnitude between how large, how small, we don't know about it. So same with the grades A, B, C, army ranking. We don't know the difference between two values, but there is a difference. So to continue, quantity data, integer or real value. So basically you might have seen here we have different type of numeric values, that is interval scale and ratio scale. So what's the difference between them? So interval scale is where the difference between the values is meaningful, but there is no true 0 point. For example, temperature, date. Temperature, date. And this you will see no true 0 point me. Give me a second. True 0 point. You might be interested in uh, knowing this. True 0 point means so at the zero value that doesn't represent anything. For example, let me explain this way. So for example, zero temperature means uh, low temperature. It doesn't means that there is no value, no quantity of temperature. Same 000 means uh, there is a value for the date, not zero means there is no date. Ratio scale, they have the true 0 point. For example, age, height, that tells that, for example, they have the true 0 point. So zero age means the person is not born. Zero weight means person weight is zero. The person height can be zero. Person income can be zero. They are ratio scale. Otherwise, temperature scale, where the difference between value is meaningful, so they don't have the true 0 point. Coming to here, interval, measure on a scale, equal sized unit. Values have order like temperature in Celsius, Fahrenheit, calendar dates. No 0 point that I just explained you. 0 degree temperature Celsius, not meaning there is no temperature. So there are different types of attributes: discrete attribute and continuous attribute. Discrete attribute has a only finite or countability infinite set of values. For example, 0, 1, 2, 3, 4, which we can count. We can count the values. There is no value between 0 and 1. There is no continuation of the values between two numbers, two categories. Example, zip code, profession, or set of words in a collection of data. It doesn't matter how long will be our data set, but it will be infinite. Zero means zero. Note. So there is one note. Binary attributes are special case of discrete attribute. Binary attribute that we discussed in last slide, they are special case of discrete attribute. There we have only 0 and 1. 0 and 1. The continuous has a real number as attribute value. Example, temperature, height, weight. Height can be 37 point this. We don't know about it, so we can go whatever you want. You might have heard that weight is between 80 and 81. The weight you are getting on your weighing machine is not the exact weight. It might be point something. So practically real values can be measured and represent using finite number of digits. So that's what I told you. So your weight is, it will show 80 point something, but it will be 80 point something something something. Continuous attributes are typically represent as floating value point. Same. So continuous mean between 0 and 1. Any value between 0 and 1, that's infinite. We can't count it. We can take our we can take our digits after these point, like whatever we want. So there is no limit. Discrete is 0 1 2. There are finite number of values. So that's basically the end of our lecture today.